what I've always done in the last many years is I will give you my advice as a leader inside a company, but then I will also give you my advice as an individual. And I think, to me, that's been one of the things that I think has bonded people to me over the years.
Hi, everyone. Welcome to Behind the Tech. I'm your host, Kevin Scott, Chief Technology Officer for Microsoft. In this podcast, we're going to get behind the tech. We'll talk with some of the people who've made our modern tech world possible and understand what motivated them to create what they did. So join me to maybe learn a little bit about the history of computing and get a few behind-the-scenes insights into what's happening today. Stick around. Hello, and welcome to Behind the Tech.
I'm Christina Warren, Senior Cloud Advocate at Microsoft.
And I'm Kevin Scott. Today we're going to be talking to a person that I have long admired, Bill Coren. I met Bill when I was a young engineer at Google, and he was one of the executives running all of the very important bits there. Ultimately, Bill went on to run search, infrastructure, security, maps, local. So this huge swath of all of the big, complicated, important things at Google. And like in a prior life, he'd been an entrepreneur. He helped run a networking company. And before that, he had been a computer science professor and was at Bell Labs running the computing sciences research division during the period where they invented things like the C++ programming language. So I still to this day am slightly in awe of Bill, and he is the engineering executive I would like to be when I grow up.
I don't blame you.
So I'm curious, Christina, just like everyone else that is on this show, including me, you've had not necessarily a straightforward path into technology. I was just sort of wondering, can you tell us a little bit about what that path has been and which mentors you've had to help guide you as you sort of figured out your own journey?
Yeah, definitely. So before I joined Microsoft, I worked in media for a decade, and I was a journalist and an analyst and reported mostly on technology and business stuff. So I did have tech, and I've always had an interest in tech, but it was obviously a different perspective. And what's kind of great when you ask about mentors, I think probably my biggest mentor would be a man. His name is Jim Roberts. He was my editor-in-chief at Mashable for a time, and he previously was the deputy managing editor at the New York Times, and he's now currently the editor-in-chief and chief content officer at Cheddar. And he's got like this great, long-standing, like old-school journalism career. But what I love about Jim is, A, we used to fight all the time, so he really kind of pushed me, right? Like we used to fight all the time. But B, he saw what was happening to the media landscape, and he decided that he wasn't just going to sit back and not evolve. You know, he was early on Twitter. He was early on embracing social and digital platforms and really pushed to get the New York Times online and to bring the two divisions. They used to be separate, like to bring the print and the online part together. And so when I switched careers, he was somebody that I kind of looked at because he, even though he didn't switch careers, was willing to evolve and wasn't just going to stand back and hope that things continued the way that they'd always been. And so even though we used to always fight, like I learned so much from him and I continue to learn so much from him. Yeah,
the thing that really always amazes me and inspires me about people who are willing to spend their time mentoring others is that these people have extraordinary generosity and sort of taking the time and then sort of sharing their perspective. And like to be a good mentor, I mean, it sounds like because you guys were like fighting all the time, like that requires a lot of energy. Like that means that he cared enough about you and your success and what you were doing that he was willing to like fully engage with you and push, which is not an easy thing to do.
Not at all. And I have to say the most gratifying thing is that in recent years, he's actually reached out to me for my input on different things, which has just felt amazing. And I know that I can do the same with him. So, yeah.
Yeah, I bet that is that's really awesome. And one of the things that that we're going to hear in my conversation with Bill is like Bill was one of the most influential mentors in shaping my career path. Like there were many, many moments where the advice that Bill gave me was perhaps the pivotal thing in like these very pivotal decisions that had these sort of long-term repercussions for my life and my family and the people that I worked with. And you know, he was incredibly busy at the time, and like he was incredibly senior relative to me. He somehow or another decided to take the time. Like, and I will always be grateful for him. And like, I've sort of had the same thing with Bill that you know, it sounds like you've had with your mentor, where I will try to return the favor to Bill and like help him out with some things that he's working on. But like maybe the, you know, sort of the biggest reciprocity there is that I was so moved and so appreciative by what Bill was willing to do for me that like I try to do the same thing for other folks. He's really informed like my philosophy on coaching and how I give advice to people. And like he's one of the reasons why more often than not will say, you know, yes when someone asks me for like a little tiny slice of time for advice.
I love that. I love that so much. And I can't wait to meet Bill.
Yeah, that's awesome. So let's go ahead and chat with Bill. So next up, we'll meet with Bill Coren. Bill is one of my engineering heroes. He's a researcher, teacher, entrepreneur, and business executive whose career includes big jobs like head of the Computing Science Research Division at Bell Labs, the birthplace of Unix, the C and C++ programming languages, and other technologies that are foundations of our modern tech world. And Bill was SVP of Search, Infrastructure, Maps, and Local at Google. Bill is now a partner at Sequoia, where he invests in, advises, and coaches tech entrepreneurs. The thing that I think everybody will tell you about Bill is he is just by temperament and sort of depth of knowledge, like one of the best people in the world to work with as an engineer. And like everybody who's ever worked for Bill wants to continue to work for Bill as long as they possibly can. So I'm thrilled that you are here with us today. I've been hesitant to ask you to come on because like we've had lots and lots of people on the show. You in some ways are the most intimidating one because I admire you so much.
You're very kind, Kevin. Thank you for the invitation. And I also, as I think you and some of the audience probably knows, I don't spend a lot of time doing public things. But with the kind invitation, I'm very pleased to be here.
Yeah, and we're delighted. So I really want to get into your story. So you got your PhD in computer science from Stanford, and then.
No, I finished my PhD and then I went to Bell Labs. I did do work as a commercial programmer while I was at Caltech, but that was a side job. But I went to Bell Labs and I did a lot of work in fluid modeling and semiconductor modeling early on, and then became interested in what today would be called distributed computing and kind of shifted to that. And then I was asked at some point to become the leader of a group, and then it ended up I stepped up a few steps and ended up as the head of the Computing Science Research Center.
So how did that transition go for you? I mean, I've always been interested in this because, you know, I think the people who have worked for you and with you admire both your ability as a technical leader as well as your technical ability, and like those two things don't always go hand in hand.
Some people think they're inversely proportional. It's interesting. I've always tried to read and explore different technology areas. My sense is, Kevin, you're the same. So I try to stay conversant. I also try to develop relationships with people that I work with who I believe are experts in the areas that they understand more deeply than I do. And I just try to synthesize as much as I can. But over the years, I've also learned, like, it's silly of me to descend into the code in a major project because I can't contribute in that way anymore. But I can think about how does it fit in end to end? What are the constraints it's operating under? There are often big choices about what to do in terms of the basic algorithmic approach and so forth, and I try to stay current with that. But over the years, it's funny, I shifted away from the numerical modeling stuff, even though it's sort of come back in the form of machine learning, and became much more deep on the distributed system side. But you can learn new things. And one of the things that always amused me when I ended up at Google was I had never worked on a web service before I joined Google in early 2003. And yet somehow over a fairly short period of time, I became responsible for the engineering associated with Google.com. So, it appears old dogs can occasionally learn new tricks. So,
I think you're being very, very modest. But you've done all this work in distributed computing, and like you had founded a network company, and so like you had tons of very relevant experience at how to build like high scale systems.
Well, so what happened to me, I started life at Bell Labs very much in the research mold. So success was writing papers and giving talks, and what was a very academic style success metric. Over the years at Bell Labs, I felt like I was going to conferences and seeing the same subset of 300 to 500 people over and over again, and I got a little bit frustrated with my ability to impact things. And so I guess somewhere during my run at Bell Labs, I decided to get more commercial. So I took over as a general manager of a business that we started, as well as the Computing Science Research Center. And I tried to start to think more about what's involved with actually building products and doing sales and so forth. And so we decided to try to put a Bell Labs in Silicon Valley near Stanford. And so I came out to do that in late 1998 or 1999. And what I ran into, I think, is a little bit of what we see today in the Valley, it was just a very frothy time. It was before the dot-com bubble burst. And, people were funding stuff that probably didn't make a lot of sense, but there was a lot of money chasing after ideas and eyeballs at that time. And I was trying to establish this sort of more traditional research lab. And after trying to do it for a year and a half or so, I threw in the towel and went off with a colleague to found a small startup in the area that was doing a telecommunications system project, and I was the CEO, he was the CTO, and we built that company up from the two of us to about 140 people. And then we brought in a CEO to do the go-to-market side. I left and was going to start another company. And then some old Bell Labs colleagues called me and said we needed adult supervision at Google, and that's kind of how I ended up at Google.
So how did you get interested in technology in the first place?
So I'm old enough that I think we call ourselves baby boomers now, but at least when I was a kid, that we were part of what was then known as the Sputnik generation, which were people who, the U.S. was responding to the space race with the then Soviet Union, and there was a lot of interest in science. And so from a very early age, I was interested in science and mathematics.
Were your parents engineers or technical folks?
No one in my family were technologists. It was just something I was attracted to, and I was reasonably good at it, and so I went down that path.
I'm just sort of curious, where did you even find knowledge back then about how to program? Did you have mentors? Were there people helping you? Were you able to find books in libraries?
I mostly found books in libraries, and then when I got access, when I was in high school, I got access to the local university's 1620 machine. I got to speak and spend some time with some of the people actually doing programming, and so they acted as mentors to help me.
Yeah, I mean, it's one of the things that I think it's easy for all of us to take for granted now is how not just sophisticated our programming systems are and how much power is at the disposal of your average programmer, but how much of the information about how to learn how to do software development, how much of computer science is all out on the internet, publicly available. There are like all sorts of useful videos explaining it from, sort of elementary, like super high level, sort of perspectives all the way down to like the deep nitty gritty research.
No, I agree. I think the other thing that's changed over the years is access to computing equipment. When I first got access with the first 2 or 3 machines, they were machines that, today would have cost the equivalent of hundreds of thousands of dollars. And They weren't machines that were in every elementary school, every high school, every home. And so there's just your exposure and availability to compute, both learning materials, but also just the mechanical machinery, the actual computing devices is much easier. Although one thing I have noticed over the years, having been a leader in different groups over the years, I think the knowledge of the actual computing devices has gotten weaker and weaker. And it's been interesting in the last few years as people have become interested in machine learning and high-performance computing again. People are rediscovering all the nitty-gritties of limited memory, cache lines, a lot of the very low-level stuff that I think the early developers, for instance, the people who created Unix, thought about how do you fit lots of capability into a very small footprint, both memory-wise and computing-wise, and we've lost a lot of that, and we're rediscovering it.
Yeah, and like one of the things that I've always noticed is, we operate on all of these high-level abstractions to do our jobs. And the engineers that I've found who are sometimes able to do the most extraordinary things are ones who sort of disrespect or are able to disrespect the abstraction boundaries, where they can sort of say, okay, this is not working. I don't understand what's going on. I'm not getting the performance I want out of this. Like there's some weird bug, and they just sort of punch through to lower and lower layers. So one of my theories about Jeff Dean, like he was a compiler guy, right? By his PhD work, and compiler folks, they're very good at, just getting this end-to-end view of computer systems and like being able to wring extraordinary performance out of things, even though like they're not actually writing the optimizer bits of the compiler anymore.
No, I completely agree with that. Having worked with Jeff and his colleague Sanjay, they both, I think, were willing to go very deep into the technology and bypass layers. And some of the people I've known for years and worked with before, like Ken Thompson, were definitely of that ilk as well. I think one of the things that modern software suffers from is, I think, people sometimes do not spend enough time thinking about what the right abstractions are and how to make them very simple. I think one of the things I've admired about Unix, which you can see in Linux today, is a lot of the very low-level system calls that were introduced in Unix have stood the test of now multiple decades because they were very thoughtful about what should be here and what shouldn't, and they didn't add a lot of complexity or cross-functional capabilities. They're all pretty clean interfaces. It's something a lot of modern software designers don't take the time and thought to do it right.
And how much of that do you think were the individuals and their taste, and how much of it was just the constraints they were operating under? I mean, like obviously, like a lot of people at the time were operating under the same constraints, and not all of them invented Unix. But the constraints have to be useful, right?
The constraints are useful, but it is true that we live in a much more complicated world now. I think in the period where some of these early time-sharing systems were built and a lot of the mini computer work that then led to the personal computer work, people had glass teletypes. They were 24 by 80 character fixed width kind of devices for output and very simple input. And now everybody expects a lot of graphics, a lot of visuals. I think just the human computer interface stuff that we do is much more complicated. And you're right. I think the best systems designers know how to think about simplicity and scalability, but our world has continued to get more complicated.
Yeah.
So
it's like one of the most interesting tensions I think we have in modern software engineering.
I agree with that.
So you get access to this machine at a local university. Like you continue to get better and better at programming. You go to college. You major in computer science.
Well, I think like many entering freshmen at Caltech, at least in those days, I wanted to be a physicist. I think probably about 90% of the incoming class at that time wanted to be physicists.
Was Feynman there at the time?
Feynman was there.
Okay, so that's a good motivator.
And I had the opportunity to meet with him a few times in the years I was there. An amazing person. But although his books are much easier to read than it is to take the exams associated with them, but that's but I think like many of the entering freshmen, I discovered I wasn't smart enough to be a physicist, so that got me into math. My first published paper in a refereed journal was actually when I was a freshman. It was a computational chemistry paper that I did with a postdoc and one of the faculty members. And I had the opportunity to do things like that during the 4 years I was there.
You remember what the paper was about?
There's an approximation to a quantum chemistry problem that's called the Hartree-Fock equations. And so this was a simulation on, at that time, a very large IBM 370 or 360 something or other that we ran overnight, and calculated a bunch of ground states of different small molecules.
That's super cool.
Long time ago.
No, but super cool. And again, like we'll get back to this later. You already mentioned that, like we have this sort of resurgence in like all of the things that like people were interested in high performance computing back in the like 70s, 80s, and 90s with all of the like large scale machine learning stuff that we're doing right now. But I think the things that you were doing back then are probably like largely transferable to like things that people are doing now to train machine learning models.
Yeah, it's interesting. When I went to Stanford, my primary work as a graduate student was in numerical modeling. My thesis was on numerical techniques for partial differential equations, fluid flow, and things like that. Did a lot of work with linear algebra and so forth. But it was all early high-performance computing work. And in those days, there were control data machines around, and Cray 1 was starting to appear and so forth. And so there was a lot of interest in different ways to do abstractions and early high-performance computing work. And it's interesting, all that linear algebra things that I got familiar with then have been rediscovered, of course, as part of the machine learning revolution that we're having today.
Yeah. Well, I mean, it's really, really fascinating. Like, I spend a bunch of my time trying to figure out like what the infrastructure needs to look like to support training very large scale models. And, like I in a very small way had been, doing work when I was in grad school in high performance computing. And it's just remarkable to me. Like I thought funny enough, when I took my job at Google in 2003, that all of the stuff that I'd done in graduate school was like gone forever, and like I would never, I'd never see the day where it was useful again. And then I'm, sitting here in 2019, and surprise, relevant.
No, it's true. And of course, the high-performance computing developed hybrid machines, NUMA architectures, all kinds of things that are reappearing now in the machine learning context.
Yeah. Well, it's sort of interesting, right? And I'd love to get your take on this. We're at this moment now where there are certain flavors of machine learning. So this simulation-based reinforcement learning stuff that, is achieved some fairly spectacular results that have been publicly disclosed over the past few years, like mostly in game playing. And then there's like recent stuff in natural language processing on unsupervised learning. And in both of these cases, like the workloads are just because you have gotten human supervision out of the direct training loop. Like you don't have to produce a bunch of label training data. Like you're sort of, in reinforcement learning, you're gathering all of your data to train the models inside of a simulation environment. And the unsupervised learning, like you just have a large like internet corpus of data that you're training on, and you're trying to like induce some structure out of it. So they're like absolutely insatiable in terms of their compute appetite. I mean, it's just mind-boggling, and at least with the unsupervised models, and I think the same thing is true with these reinforcement learning models. The more compute that you can throw at them, like the better the results you get. And so like there's just this real tangible incentive to like throw the more compute. And it's happening at exactly the same time where Moore's Law is running out of steam. And like, it's not Moore's Law that's the problem, it's sort of the Dennard scaling that's the problem. Like we can put, tens of billions of transistors on a die now. We just can't power them all.
Correct.
And so like we really are having to like revisit computer architecture and, like how do you cool these things? Like how do you design their networks? Like what is the memory hierarchy? I mean, it's just crazy that all of this is relevant again.
No, I agree, and we're having obviously a revolution again in computer architecture for all the reasons you point out, and John Hennessy and Patterson just won the Turing Award for basically having thought about computer architectures in different ways, done RISC, written their book, and kind of. I think they reopened the door as part of their Turing Award speech and some of the speeches they've given since, suggesting it's time to rethink computer architecture.
Yeah, so, I completely agree with them.
The other thing that's been interesting with the insatiable appetite for computing, and it worries me a little bit, I still believe that universities are the best training ground for people doing computer science work. Maybe not everybody should take the time to go get a PhD, but I think that having a rigorous program with lots of mathematics and theory and so forth, and it's more than just programming. But I think one of the challenges with the rise this time of machine learning is I think the universities are at a disadvantage because, the big platform companies, which of course would include Microsoft, Facebook, Google, Amazon, and others, are the best place to get your hands on lots of data and lots of computing resources. And I think it's very hard for MIT or Caltech or, Stanford to compete with those capabilities. And so I think it does call into question what's the right partnership between universities and these large companies because I think otherwise we're going to have a lot of people who are deficient in their training as they enter the workforce and try to do novel things.
I completely agree. And it's become especially obvious, I think, over the past year where some of this stuff on like the very frontier of AI, like the computations have become so large and it's so expensive that like we even, sort of have to think carefully about it inside of like these big tech companies. Like you can't have 5,000 people all, like doing each a $10 million computation to train their model. Like you have to sort of think about like how you want to focus these efforts in ways where you can, where you can get leverage out of your compute infrastructure. And I think it's especially hard for these universities. I've joined the advisory board of the Stanford Human-Centered AI Institute, and thinking in general about like how we can form these partnerships where we can make resources available. I think it's beyond just training, though. You also really need, sort of dispassionate third parties, pushing in interesting new directions. Like one of the things I really worry about with the state that we're in machine learning right now is that we have made a bunch of subjective decisions about how these computations should be performed by virtue of the frameworks that we've built. And so like it's sort of like MapReduce, right, back in the day. So as soon as you have MapReduce, it's like such a powerful abstraction mechanism that it solves like a ton of different problems and like abstracts away like all of this tedium for, like how to, massively, in distributed fashion run these workloads. And, the tool is simple enough and powerful enough where all of a sudden like everybody wants to try to bend their computation around where it's like a MapReduce job. And I think we have a little bit of that right now. I mean, so like you look at these deep learning algorithms, like whether it's TensorFlow or PyTorch or like the numerical kernel of all of these things is stochastic gradient descent. And like because you've chosen SGD is the way that you're going to like do the fitting for the models, it just sort of excludes a whole bunch of things that you might want to do. And so like we in a real sense have been pushing people down to this, like what has to be a local, like a local optima. And, I would love to have like just a much, much larger pool of people sort of pushing at those assumptions. But in order to do it and to compete, to show that the new thing is as effective as the, the old thing, like they have to have the compute resources.
I agree. And I think the other thing, which of course has happened more and more with machine learning, is not only are we constrained by the frameworks, but we're also, I think, even in the unlabeled case, the case where you're not pre-labeling data and you're doing unsupervised learning, I think you have the risk that if you feed it the wrong sets of data, you can generate biases of various kinds without even realizing it, and it's tricky. There have been a number of published results on this stuff, but it's kind of insidious.
Yes. So let's go back. So tell me a little bit more about this this experience with starting a company, because that is a very unique thing. It is not at all like managing researchers. It's not like, even though Google hadn't gone public when you got there, like it was already a reasonably
it was 400 or 500 people.
But like 0 to 140 is like, I mean, that's something else.
Well, you learn to tell stories to venture capitalists. So now that I'm doing that as a full-time job, you get to play the other side of that drama. But you have to think about what's the product you want to build, what kind of team do you need, how much funding do you need. You have to think about everything. And starting, as you say, from zero, you've got the challenge of, you're the janitor when day one starts, right? And so you have to think about everything. You laugh. I did the payroll and the bookkeeping for the first few months. Not that I'm particularly good at that, but I can do a little bit of accounting math.
Yeah. Well, and it must have been good preparation for what you ultimately had to do at Google, because at some point you weren't just an engineering director of like a group of people. You were sort of like the CEO of like an army of engineering people. And so like you had HR issues, you had finance things, you had facilities things. I mean, like I remember walking into your office at one point, where you were sort of looking particularly exhausted. And I was like, what's going on? And like you had this spreadsheet in front of you, like where you were trying to like figure out where everybody was going to sit who was being hired in the next unit of time, which which is probably very far away from writing papers about, ground state simulations of quantum chemistry systems.
No, it's true. I think the role I fell into at Google was I was willing to take on stuff that not everybody else was willing to take on. So there was a small executive committee that ran Google, of which I was a part for a number of years, and I for a while worried a lot about things like facilities and HR, and you have to do this in a young company. You have to do what you need to do to make it successful. And part of the challenge, and you saw this at Google, I'm sure you also saw it in your experience at LinkedIn. It sounds very hard to go from 0 to 140. It's also very hard to go from a few hundred to several thousand. The scaling, trying to figure out what works. You want to introduce more process and structure, but if you introduce too much, it kind of kills all the energy and excitement in the team and so forth. And so finding a path through a heavy growth phase of a company is pretty tricky. And I did a lot of that for Google in the early years.
What do you think was the most challenging thing or problem that you had to solve in those early years?
I didn't join Google until early 2003, but I think from when the dot-com bubble burst to probably 2004 or 5, recruiting was hard, but it wasn't crazy like it is today because there weren't enough kind of growing, powerful new companies forming because of the sort of downdraft that happened because of the dot-com burst. I think today, one of the challenges I see with the young companies I work with is just figuring out where to recruit, what to do. One of the things you see from more and more companies is looking at doing engineering away from Silicon Valley.
Yeah.
And then I think one of the biggest challenges I saw in the early days at Google was it was still very much a startup, even though when I joined it had a few hundred employees. And there were key areas inside the search product, for example, where only one or two people actually knew some of the key things to get things done. And so one of the challenges that I found particularly hard was figuring out a way to not disempower and take responsibility away from the people who'd been standing in the breach, so to speak, but building a team around them so that you could actually have turnover and have organizational stability. But you sort of transition from a few kind of superhero type people that know all these key things to teams that actually own things. And that's an enormous cultural change, which we went through. I think we managed to preserve a lot of what was good about the original culture, but it's hard.
Yeah. Just sort of outside looking in, like one of the things that you always seemed to have a real talent for was managing the very senior, like very most capable engineers and like figuring out how to, give them the space to do their best work without like sort of having the crush of like all of the sort of outside world and, sort of friction that can sort of land on you as an engineer. I mean, like at one point you had like almost all of, or maybe all of the principal distinguished engineers and fellows reporting into you. Like they're not an easy group of folks to manage. I mean, I know many of them. I love them. Like they're like fantastic human beings, but they're smart. They have strong opinions. Sometimes their interactions, with one another or like with other engineers are sort of like interesting and like. But somehow or another, like you built this environment where all of these folks could like really flourish because at some point, like they don't have to work for you. They don't have to work at Google. They can do anything that they want to do.
So I think what I tried to do, and I think I was successful more often than I wasn't, that was find areas that were important to the company that different individuals were interested in. That's how we spawned a project called Borg internally to do cluster management. There were a group of people. If you look at the work that was done there, it was very good. It was very deep. It was ahead of its time, but it also was rediscovering mainframe time sharing but on a cluster.
Right.
And so some of it was recycling ideas that were prevalent in the 60s and in the early 70s, but finding the right set of people that were interested in that problem, were motivated by the problem, and putting them together. So finding things that were interesting, we had the challenge of managing locking and global namespace stuff, and that was an area that Mike Burrows was particularly attracted to and did a terrific job with. And I think so. It was just picking individuals, but it didn't always work.
That particular one is sort of genius, like sort of saying like, here's this person who can work on these problems, and like we're going to go build infrastructure that everybody else can use. I mean, those are some of the hardest problems in software engineering, like proving that, Paxos is implemented correctly in like one of these locking systems. And like Mike is, maybe the best person in the world, like one of the best persons in the world.
No, I agree. And Google had it still has people that are absolutely world class and strong. But you're right. Some of them don't mix well together. You have to figure out the right problems, and it didn't always work. The other thing I often tell young companies that I work with now is Google also could cheat, and I don't mean that in a nefarious way. With the advent of AdWords, it started to become, lots of positive cash flow, it gave flexibility. The fact that the business was so strong gave us access to resources and capabilities we wouldn't have had. And one of the things I always find amusing is when I am working with a very young company and they want to talk about creating 20% time. And I often will tell them, when you have a massively profitable business, why don't you come back and ask me about 20% time? So I think people need to be more realistic about what constraints you're operating under. And at Google, one of the things I did is, like, we started storage projects we weren't absolutely sure we would need because we had the flexibility. In another company, you wouldn't do that. Most of those bets turned out to be good bets, but not all of them.
Yeah.
So.
Well, it's sort of interesting, like even 20% time, like there are things like that take on these mythological proportions. And like, I don't ever remember using 20% time. And it wasn't because I didn't think it was available. It wasn't because my manager wouldn't have supported it. It was because I was so interested in the work that was my 100% time that I didn't want to stop doing that to go do this other thing. I mean, it was nice to know that I had it if I wanted to use it, but I think a whole lot of people...
Most people did not use it.
Yeah.
And not everybody had an exciting new project they wanted to start on their own. So.
Yeah. The thing that I really enjoyed out of Google as it was growing as fast as it was. So I was there, like I joined, I guess a few months after you did in 2003, and then I left the first time in the middle of 2007. And the thing that was just extraordinary for me over that period of time is, like, because we were growing so fast and we were solving so many problems for ourselves the first time, you got to be this sort of participant in the unfolding of like this really interesting, great business and this really interesting, great technology stack. And you sort of got to see, okay, this worked, this didn't work. And like in a very quick period of time, like I felt like I got exposed to like a whole bunch of things that I never would have been able to get exposure to if I had been at some place that wasn't growing that fast.
Well, I think that's right.
Like when I left to go do AdMob, to, which was already a company I joined in 2007 to run the engineering team, when it was like the whole company was about 25 people, I think. And like I felt, just because I'd been able to raise my hand and say, oh, yeah, like I'll go help with the mentorship program. I'll go help set up a faculty summit. I will go, like you need someone to go do diligence on like an M&A thing that we're doing. Like none of which I was qualified to do when I raised my hand, but because no one else was there who was raising their hand to do it, like I got all this experience. And when I went to AdMob, it was like, okay, like there's still a whole bunch of stuff I need to learn, but at least I'm confident in like a big enough set of things where I can I can have some modicum of comfort that I'm not going to screw everything up.
Yeah, I mean, you can learn a lot, and you get a lot of advancement and opportunities to do different things, right? It's a special time in many companies.
So you were at Google for how long? You left in 2011, so you were there for
8.5 years, I think. Yeah.
And so, what was the biggest team that you had? So you were up to 5,000-6,000 people.
It was probably a little bit north of 6,000. Google broke itself up into product divisions they call product areas, and I think at one point I had amassed what are today 4 or 5 of their product areas.
So let's talk about the transition to venture capital. So you've been doing this for, I guess, almost 8 years now.
Close to 8 years. Yeah.
And so, like, what made you could have done anything. You could have stayed at Google. You could have, gone to another company and done a similar thing. You could have started a company. You could have retired. You could have, you could have basically done whatever.
Yeah, I think when I look back at my career, I thought, one of the challenges of the role that I had at Google is I was unsure what I could do at another company that wouldn't feel like a step down. And it's not that I'm in love with a particular title or a particular role, but there aren't a lot of Googles in the growth phase out there. I think there are probably a small number, but they're very few and far between. And so I didn't see how to repeat that. And I think one of the things I've gotten better at over the last 10 or 15 years is mentoring and spending time with people and helping them think through their problems and their challenges and so forth. And it felt like I could do that as a board member, as a mentor to a bunch of young companies. And so for me, some of it's what people I think call giving back, but some of it is, I think at this stage of my career, I'm probably better as a coach than as a player.
Yeah. Well, I mean, I remember some of the best advice that I've ever received has been from you. And I remember just vividly this one sort of critical moment in my own career. So this is when I was thinking about leaving Google to go to AdMob. I chatted with a few companies. Like I had chatted with Omar, who's I guess now one of your partners at Sequoia, who is like the founder and CEO of AdMob. And I remember I asked you for a meeting, which you were always generous enough to take when you were much, much busier than I was. And I remember coming into the room and I was like very reluctantly admitting that it's like, oh, I've been out talking to these companies and like I'm thinking about leaving. And you already knew because somebody had, whose name I will not name,
Yes, I think I know who, yes.
had done a background check, I'm guessing. And so, but you gave me the best advice. You were like, okay, like here's the advice I'm going to give you with my Google hat on, which is, whatever that was. And then here's, the advice that I'm going to give you without the Google hat on, which was just super helpful to have both of those perspectives and making that decision, which was really hard. Like I had a hard time leaving because it was really, it was a great company and I had so many friends there and I felt so grateful for the opportunity that I'd gotten, which I think a lot of it was luck. There's no way that... There's
a lot of luck in many outcomes in life.
There's a lot of luck, just extraordinary amounts of it. But, I've like that advice you gave me was like one of the... and it was certainly like a pivotal moment. Like my experience with AdMob, like without that, I wouldn't have been able to, get the role that I had at LinkedIn. Without the role at LinkedIn, I wouldn't be sitting here as CTO of Microsoft. And so, I'm glad that you're out there, like giving other people this like really good advice. What made you decide that like this is the sort of thing that's worth your time? because you were doing it even before it was like officially your job as a venture capitalist. You didn't have to take that meeting that day, or like any of the other times, because I was way below you in the org, and you weren't just doing it for me. You were doing it for a bunch of other people.
So and maybe this is one of the things I've tried to do as a leader. I think most people, when you're employed by a company, you're employed by Google. Now I'm employed by Sequoia Capital. You have to have loyalty to your employer, but I also think as a leader inside of any organization, you also have to be authentic, and you have to. If somebody asks you for advice, they don't want the company line. They want real advice. And so what I've always done in the last many years is I will give you my advice as a leader inside a company, but then I will also give you my advice as an individual. And I think, to me, that's been one of the things that I think has bonded people to me over the years, because they feel like they're not getting a bunch of political mumbo-jumbo, which unfortunately I think particularly folks in large corporations, I've known a number, they can only talk in the sort of party line mode, and they never get out of it. And it makes them appear, even if it's not true, as phony. And so I think part of it's just being genuine and authentic when you talk to people. So,
it's sort of scary to do, because when I was running engineering and operations at LinkedIn, which grew over the course of the 6 years that I was doing the job, from a couple hundred people to about 3,000, like I took this cue from you that I was going to try to be as authentic as possible when someone came to me and like they were struggling with a problem, and like trying to figure out like what the next step was for them. And like I would do almost exactly the same thing that you did for me. Like if they were contemplating a job offer, it's like, here are all the many reasons why I would like you to stay, like because we really need you here, and like we walk through the whole thing, and then I would give them my unsolicited advice, and sometimes it would be like, hey, I don't think that this is like based on what I know about you and what you told me about your aspirations, like I don't think that this is a good move for you. And sometimes I would tell people, it's like, this isn't a bad option. Like you are now faced with a tough choice. Like I think it's you've got a good option here and you've got a good option there, and and the thing that I found, though, like even like this horrifying thing, like when you are leading a group of people, and like you in a very sort of very concrete way are dependent on them to like be able to achieve all of the things that you're trying to get your company to achieve. But I found like having those conversations, like I think because people believe that I had a genuine interest in their success and their happiness, like I wound up being able to hold on to a bunch of people like way longer than I would have otherwise.
I think that's right.
But it was hard to do because it feels very scary.
Yeah, it's risky. It feels risky. I understand. I think the other thing, which I saw at Google, and I suspect you've seen in your arc too, is Google hired a lot of very bright kind of new grads, or it was their first or second job. And it was fairly common for people after a few years to kind of wonder what the world looked like outside of, the particular confines of Mountain View at the time. And that's not irrational for a young person. And on the other hand, Google wanted to retain those people. And that there were some difficult challenges in that.
Yeah. So what are the most interesting things that you're seeing in venture now? So like it is an exciting time right now, because there's a lot of venture capital out there. It's never been easier to start a technology company because you have open source, you have all this cloud infrastructure. You have like an increasingly powerful set of capabilities that let small teams accomplish big things. And like you're at Sequoia, which is like one of the top venture capital firms in the world. So like what's interesting right now?
Well, there's clearly a lot of interest in software around machine learning.
Yep.
I think that there's a bunch of companies trying to create tooling or do vertical applications. I think there aren't very many companies proposing to do platforms because you've got TensorFlow, PyTorch, and other things in the market from companies that have obviously much larger resources than you can mount from a startup. But the sort of machine learning software and getting machine learning that's usable and digestible by a broad community is very hard to do. And I think there's some interesting ideas and companies around that. There's a lot of interest in processor technology, both for machine learning, but also I'm starting to see some companies that are talking about rethinking more server processors more generally and so forth. And so I think there's a lot of that. Those are harder companies, I think, for venture capital, just because it requires hundreds and millions of dollars of investment rather than tens of millions of dollars of investment. So I think. But I see interest in that area. There's a lot of interest in quantum computing, which is, people will debate whether it's about to go commercial or whether it's still going to be research for a few more years. It feels to me like we're on the cusp of a bunch of things right now in that area. Those are very interesting. And then they're interesting companies in storage and networking and so forth, but I think the big things have been processors, machine learning, and then quantum are areas that I think are particularly interesting.
And the processor trend, aside from the machine learning stuff, like we're seeing with distributed systems right now, that like architecturally, like one way to compose these things now is streams and stream processors. Which are going to have different compute requirements than normal sorts of processors. There's also like this interesting thing where you sort of reach your sort of power saturation point with transistors for logic, but you haven't yet for memory cells.
Yeah, I think there's trade-offs now that people are rethinking about between actual logic type processing versus memory. What kind of embedded memory do you want? What kind of memory structures? There's obviously new kinds of memory coming into the market that don't require DRAM refreshes but are faster. That's another area that may be interesting. I think the other thing which strikes me as a big challenge as people think about processors themselves is there's been some fascinating work on the security side and very scary. People did not think through all the risks with speculative execution. Yeah. And on the other hand, if you throw speculative execution out, you hurt performance a lot. And so I think there are people trying to think about how do you think more from first principles about what the security risks are in processor design. Right. So that, because when you admit security weaknesses at the very bottom layer of the hardware, it's pretty hard to defend against. Yeah. And it's scary in new ways, right? And so I think there are a lot of interesting things happening in and around that area.
Yeah. Are you seeing stuff with the in the IoT space? Because the processors there like still have a couple of generations of real Moore's law left in them.
So we're seeing a bunch of companies around. There are a lot of people looking at processors for the edge where they can do some inference, maybe a little bit of training.
Yep.
I think, and very low cost kind of microcontroller level designs and so forth. There's a number of interesting new ideas and companies in that area. When I've looked at IoT, I've mostly looked at things related to industrial IoT because I think consumer IoT has been tricky for a variety of reasons. One is it's often driven by brand and consumer reach, which I think advantages companies like Apple and others. And I think the other thing is smartphones are too good at doing a lot of different things. And so the killer apps for the consumer IoT, I think, has been pretty limited so far.
Yeah.
Personal opinion, but there you go.
Yeah, I mean, we can certainly see that the industrial IoT stuff, like the applications there are like rich and like there's an enormous amount of opportunity there. I think we sort of see the world in similar ways.
Yeah, no, it's consumer IoT. I think more and more devices are connected and are, have some ability to respond to command and so forth. And we'll see a proliferation of that. But special use cases, I think, there aren't enough interesting use cases. I talk to people that have Alexa devices or, the Google Home devices and so forth, and they use them to set alarms and timers and play certain kinds of music and so forth, and then they rapidly seem to run out of other things they can do with them.
The thing that I think is a little bit interesting, though, is that the capability in these devices already, like in both the hardware and the software, is much higher than what we're using it for.
Absolutely.
So, like just as a proof of concept thing, like I'm building a AI coffee machine right now, which probably sounds weirder than it actually is. But like the idea is, can you build a consumer appliance from scratch, like as an individual, although like, one with slightly more resources than an average individual. But like, can you build a device that has like a modern AI powered user experience in it? And so like this thing will have no buttons, no displays, and it will have a camera, a speaker, and a microphone. And so like when you walk up to it and like it knows that you're paying attention to it using very straightforward computer vision models, it will say to you, can I make you a cup of coffee? And it will be able to recognize who you are and remember your preferences.
Yeah.
And
and
like that's an entirely doable mode of like building a user interface on a consumer device right now. And it's going to be not too terribly expensive in the not too distant future. Like I'm going to be able to do this with $30 worth of electronics, and like the price of that's going down to $2 over the next few years, I would imagine.
I think you'll see that in a lot of consumer devices, but there'll be very limited narrow use cases, right? So.
I'm just super excited about what's possible there. So I want to get people inspired to do more.
Oh, I think human interfaces that are voice driven and have some aspect of computer vision is clearly where things are going.
Yeah. Awesome. Well, thank you so much for taking the time to talk with us today, Bill. It's been a pleasure.
It's been my pleasure to be here. Thank you again for the invitation.
Awesome.
Well, we hope you enjoyed Kevin's interview with Bill Coren. So, Kevin, one of the really interesting things that you and Bill were talking about is kind of how what was old is kind of new again, and kind of how the tech that was the problems that we were trying to solve in the 70s and the 80s and even the 90s are now kind of coming back in vogue again. Why do you think that it is that those problems are still relevant and that we're still going back and kind of revisiting some of those ideas?
Yeah, it's amazing to me how cyclical technology is as a business. Like I've been coding since I'm 12. I'm 47 now, so 35 years-ish of like paying very close attention to what's happening in computing. And like just inside of like that 35 years, like there have been multiple cycles where you'll like have this intense enthusiasm for a thing, and then it will sort of fall a bit out of fashion, and then the next thing comes in and you'll sort of forget temporarily all about the old stuff. I think these older technologies that pop back up, it's almost a puzzle why they went out of fashion in the first place. So like you look at high performance computing, for instance, we were building in the 70s, 80s, and 90s, like these very sort of idiosyncratic, supercomputers and very high performance machines that all were different in little ways. So like they had a good idea about how to do the memory hierarchy, or a good idea about how to do networking, or a good idea about how to split the computation up across a bunch of different processors. And the thing that caused them to go out of fashion is like there was this sort of catalyst, driven by the rapid growth of the internet to sort of standardize your computer architectures on commodity CPUs, commodity memory, commodity networks, like commodity everything. And so like you just sort of created at massive scale, like large amounts of compute where all of the like individual units of compute looked exactly the same and were built as cheaply as possible. And like that works really well for, sort of the problems that we had for the first 20 years or so of like the commercial explosion of the internet. What we're seeing right now is like the problems are different again, but like different in the same way that they were like a bunch of years ago. And so like now we're digging back up all of that good work that folks did a few decades ago and are realizing like how valuable it still is in these new contexts. It's really fun because I spent a bunch of the early parts of my career thinking about these things. Like I did an internship at the National Center for Supercomputing Applications, like where we, when I was there, we had just taken delivery of this machine called the CM5 from a company called Thinking Machines, founded by famous computer scientist Danny Hillis, who I hope we will get to come on this show at some point. Like Danny's like super awesome human being, and like just like maybe the most brilliant mad scientist I've ever met. I love Danny. But anyway, this machine was just epically big and like epically cool and just sort of, it was a challenge to program this thing, but like when you could harness all of its power, it could do miraculous things. And I never in my life would have thought that all of this stuff that I did back in the 90s was going to be relevant again one day. So it's like really, I'm sort of glad that technology has these cycles because it's almost like I get to do two things at once, sort of be nostalgic about like all of this cool old stuff, and like I get a set of techniques to solve a set of problems that are very relevant today.
I love it. No, it's so cool to be able to revisit the past, but also use the advantages that we have now when solving those problems. That's great.
And the cycles are like can be really long. Like the other thing too, like I think is we're thinking about AI right now and some of the disruptive effects that it could potentially have. Like we're learning lessons even from the Industrial Revolution, which is like not just a couple of decades ago, it's like centuries ago.
No, that's so true. I hadn't even thought of that, but you're right. I mean, these cycles can be really long and we can learn lessons from them, or hopefully we can, right?
Yeah. So the message for the young ones is like pay attention to history. Very, very important.
Okay, so we need to wrap up. But before we do, remember to tell your friends, your colleagues, your neighbors, your barista, your Lyft driver, your dental hygienist. Real talk, I actually have told my dental hygienist and my dentist. I have. Okay, you get it. Tell everybody you know about the show, and you can write to us anytime at behindthetech@microsoft.com to give us your feedback and tell us what you'd like to hear more of.
Yeah, we really would like to hear from you. See you next time.